right, 3.2 starts our conversation of a type of diagram for analyzing arguments. And you're not going to see why it analyzes them very well in today's lesson specifically. But again, this is one of those things that's going to build upon itself, so you'll see more of how this can be used once we get toward the later sections in this chapter. But truth tables is one of those arguments. And we're also going to talk about at the end of this lesson, which won't be today, about equivalent statements. All right, so the first statement, or the first definition I want to bring up is a word you've seen before, and it showed up in 3.1. The word is conjunctions. Conjunctions are true when both statements are true. That's conjunctions. So do you remember what the word was from that table that we ended with last time for conjunctions? From yesterday or Friday? Are you finding it for us, Alex? There's disjunctions and conjunctions. What was the conjunctions word? Conjunctions and. Somebody said it finally, and. The word is and. So whenever you see conjunctions, this is talking about the word and. It had the symbol that went upside down B. That was and. So that was from our table last time. This is the same word, conjunctions. And I want to talk about what a truth table looks like. So we're going to do a truth table for the statement P and Q. And as we create this table, I'm going to argue for you why this makes sense using some statements. So here's P, here's Q, and then we're going to have a column for P and Q. So if I have two statements and they're joined by the word and I'll make up some so we can talk about the final column in this in a moment. One possibility is each of those individual statements are true. So I could have the first statement's true and the second statement's true. They're both true, and then we move on to the last column. That's a possibility. The second possibility is the first one could be true and the second one could be false. Our third option is that the first one could be false and the second one could be true. And what is my last remaining option? False, false. Now, here's the deal. Every time you set up a truth table and you've got two statements, you will always have the first column T, T, F, F. And you will always have the second column T, F, T, F. So no matter what happens next, you can start this problem. Make sense? Okay, and all this is it's just showing you all the different ways two statements can be joined and be either true or false or whatever the situation is. These are only four options, okay, for statements. So let's see. We're going to do the statement. We'll do the first statement as, we'll make it nice and gender neutral, he, she. Teaches. Okay? And we'll do the second statement as he, she. Let's go with plays piano today. That sounds like a good one. So, we have somebody coming into the room, and the somebody that comes into the room teaches T, right? The T is in the teaches column, and plays the piano as well. That's the T in the plays the piano column, the Q column for plays the piano. So they're both a teacher and a piano player, and they come into the room, and they make the statement to you, I am a teacher and I play the piano. Would that be a true statement if each individual statement were true? Yes, it would. This would be true. Okay. And then right after them, someone comes into the room, and the person who comes into the room is, let's let them be a secretary. I don't know, that's just what I made up, okay? So they're not a teacher. They're a secretary, they come in the room, they're a secretary, but they're also a piano player. Okay, so they're a secretary, they're a piano player, and they come into the room and they say to you, I'm a teacher and a piano player. Would that statement be true? No, because they're not a teacher, right? And that word and in the middle would have to mean that both of those statements would have to be true for that statement to be true when it was combined. So this would be a false statement. Because they're not a teacher. What's that?
Wouldn't it be
Oh, the way that I just structured my words, yeah, I would. I'm sorry, I didn't mean to go out of order. No wonder you're giving me funny looks. We'll go back to the one I missed then. Okay, so they walk in the room, and they're a teacher, and they're not a piano player. They play drums. Why not? They play a drummer. All right, so they're a drummer, and they're a teacher, and they come in the room, and they say, I'm a teacher and a piano player. Would that statement be true? No, that would not be true. So this would be a false statement. Okay. And then we have somebody come in the room, and they're a secretary and a drummer. But they come into you and they say, I'm a teacher and a piano player. Would the statement be true? No, it would be false. So anytime you're dealing with a statement that's joined with the word and, in order for the combined compound statement to be true, each of the individual pieces must also have been true. That's what we mean in our language when we say and between something, right? If I say, I'm a teacher and I am a mom, it means that I am both of those things. It has to be both of them true, otherwise the whole statement wouldn't have been true to begin with. Okay, so this is a conjunction. We also have disjunctions. So I know you have to write something down, but somebody tell me before you write. A disjunction is what statement? What word? Somebody's saying it's or. And the symbol we used for or is a V. So a disjunction is true when either one or both statements are true. So we've got a P or Q. And my truth table starts, well, exactly the same way, actually. I make 3 columns. One column is P, one column is Q, and one column is P or Q. Somebody tell me what column P is going to say underneath it. TTFF. And it's always going to do that, isn't it? Somebody else, what's column Q going to say? TF, TF. And it's always going to say that no matter what comes next, right? You got 2 statements. It's going to be 2 T's, 2 F's, and then they're going to oscillate. All right, the last column is an or statement. So let's use some people this time, or we'll do some ones that you've got examples of. All right, so P is going to be, we'll make this easy. This is teaches math. That's not a good T. Pretend like that word looks like teaches. This one's teaches math, and Q is going to be is a mom. Because that way I can use myself as an example. Oops. All right. So I walk into the room, and I say to you, me personally, I walk in the room and I tell you, first day of class, I teach math, and or I am a mom. Because the word is or between them, right? It's the V, or I'm a mom. Is it a true statement? Yes, it is a true statement. I teach math or I'm a mom. This is true. Okay, so then Dr. Kelly, no, I'll use him in a minute. How about we use Dr. Nichols? I don't know if you guys know Dr. Nichols, but Dr. Nichols is one of my colleagues in the math department. He walks in one day, he's going to substitute for you, and he walks in and he says, I teach math or I'm a mom. It would be an awkward thing and a strange thing for him to say, but he says it anyway. And is it a true statement? Yes, it is. Because all it has to be for a true statement, for an or statement, is one statement or the other one being true. He does teach math, so this would be true. He teaches math. He's not a mom, but he teaches math. All right, then we have oh goodness. How about so Tyler, tell me your mom's name.
Debbie.
Debbie. Okay. So Debbie Hill, Tyler's mom, walks in the classroom and she says, I should have asked you, does she teach math? No, good. Then that'll work. Whew. Man, narrow miss on that one. All right, so Debbie Hill, is it Hill? I didn't ask you. Okay, so Debbie Hill walks in the classroom and she says, I teach math or I'm a mom. Is the statement true?
Yes.
Yes, the statement is true because she's a mom. She's Tyler's mom, right? True. All right, now we can use Dr. Kelly. All right, so Dr. Kelly walks in the classroom and he says, I teach math or I'm a mom. Is it a true statement? It's not. If you know Dr. Kelly, what does Dr. Kelly teach? Bible classes. Religion, right? He teaches over in religion. He does not teach math, is the point. Okay? And he's not a mom, right? He's a guy, so he's not a mom. Just in case you aren't curious, Dr. Kelly's a man. Yes, so this would be a false statement. If he comes in and he says, I teach math or I'm a mom, that would be false because both of those individual statements were false. Okay? This table looks different than the last table, doesn't it? On the last table, we had one true statement, and it was the very top where there's a T and a T together. And then everything else was false. On this one, we only have one statement that's false, and it's the very bottom. Right? Both of the statements are false, and the whole thing's false. But they do have some things in common as well, yeah? If you have two true statements and you join them with and, it's true. If you have two true statements and you join them with or, they're true. If you have two false statements and you join them with and, it's false. If you have two false statements and you join them with or, it's false. It's just the middle two that are different. Right? And it matters. The word or and the word and are not the same word, and they don't mean the same thing. You have to use the English logic with what's going on. Okay, we have one more in this section, and then we'll pause for today. We'll do number 1. We'll come back to number 2. Number 1's still on your front page, isn't it? Those of you who have the notes printed out, okay. This says let P represent a false statement and Q represent a true statement. Find the truth value of the given compound statement. So anytime something talks about a truth value, what you're going to do, and you are going to show the work in this way, okay, you are, is you're going to start out like you're making a truth table. Okay, whatever statements, P's and Q's and R's and T's and whatever letters are there, you're going to put them in a header. This one only has P in it. That's the only letter that's in this statement, tilde P, correct? Okay, so P is the only letter that's going to be in this truth table. The second piece you're going to do is then combine whatever you need to do to combine these so that that piece is also in your truth table. Tilde P on this one. So far, so good? Now here's the cool thing. You don't have to create a whole huge table. And the reason that you don't is because they actually give you a very useful piece of information. They tell you that P is false. Don't they? So right underneath where P is, you can write false. Because they gave you that. And if P is false, what's tilde P? True. Remember, tilde means it's the opposite. It's the negation of. If something's not false, it's true. If something's not true, it's false. It's one or the other. You can't be in the gray area. There is no, I'm sort of kind of pregnant. You either are or you aren't. Right? Okay. This was going, it's true or it's false. Okay? True or false. So, this one was true. The last thing you have to do is actually write it down. The answer to the question is true. The work that supports it is the table you created. Okay? Let me do the next one so you can see it with the P and the Q. I know I said I was going to stop, and I lied. I'm sorry. We'll do this last one. All right, so what letters do you see? There's a P, so I need a column for P. There's a Q. What else? There's a tilde, but the tilde is outside some parentheses, right? So what would you do first? Yeah. So just like with algebra or whatever, we work from the inside of parentheses out, right? Like order of operations, PEMDAS. Remember that from an algebra class. We will do the P and Q next. But as we mentioned, or as Mason mentioned, there is a tilde, right? So we do need a column that represents that piece as well. So that's where we're joining all of it together at the end. All right, more or less. Okay, using the information back up at the beginning, we were told P is false. So we're going to write an F underneath the column for P. And I didn't actually underline it yet, but it also told me something about Q. It says Q is true. Okay, you're given those pieces of information. If you're ever asked to find a truth value, it's because they gave you whether the pieces themselves were true or false. In essence, you knew who was walking in through that door, so you could make the assessment about whether their statement was true or false. Does that make sense? All All right, so this is now an and statement. So remembering back to and statements, when are and statements true? When they are both true. And these aren't. One of them's false. So when I join a false statement and a true statement together with an and symbol, this little block right here is false. And then moving from this block over to here with the tilde in front of it, it makes it true. So this result here at the end is that this is a true statement. And I know that at this moment right now you're thinking, I'm just playing with symbols. And I am. But we're going to put the substance behind the symbols once we get this playing with symbols down later. Make sense? Awesome.